by the results of full-scale tunnel testing of the Avro car at NASA Ames Research Center, a continuation test program was begun. The objective of this program was to prove the effectiveness of the new control system from hovering through transition in the presence of the ground up to free flight conditions. The program consisted in the main of further wind tunnel tests at Ames Research Center to prove the effects of these modifications, with a short flight test program at Avro to establish that the hovering capability had not deteriorated. A brief terrain test program was later added. During this 6-hour flight test program, various minor experimental modifications were therefore made to the hovering control system and to the central jet configuration. The forward speed of the Avro car, with the transition doors closed, was found to equal the speed previously achieved. Operation of the transition doors was attempted, but it was determined that the pneumatic boost available for the control system was not sufficient to overcome the large asymmetric load on the focusing control ring. A more powerful control actuation system is planned for future development. In its current configuration, the Avro car was operating successfully in the ground cushion at a height of 3 feet and speeds up to 30 knots. It was now desirable to extend the Avro car's operation, and the program was extended to include flights over various types of unprepared terrain and natural obstacles. Again, the Avro car covered the course successfully, becoming, as far as we know, the first ground effect machine to negotiate obstacles of this nature. The vehicle had now clearly demonstrated its ability to operate over unprepared terrain, and landing pads were installed in place of the wheels for the following phase of testing, which included operation over soft ground. A number of flights were made over this course, which had a rough, eroded grass surface and a short 1-in-8 gradient. During most of these early tests, ingestion of low-density material presented some difficulty. In an attempt to reduce the ingestion problem, screens were fitted to the engine inlets. No great improvement was achieved, as the coarser material tended to block the inlets, while fine particles still reached the fuel control filters. Introduction of additional filters resulted in some improvement, and it is anticipated that this handicap will be overcome with little difficulty during further development. In preparation for the final contractual demonstration, a representative course was selected where the vehicle could demonstrate its capability while remaining in view of the observers. The course was laid out to cover concrete, grass, and gravel surfaces, and included 4 ditches. Precise directional maneuvers were necessary to avoid surface obstacles. In previous flights, the Avro car had always flown directly over ditches encountered in the course. In order to prove that the ground cushion was not destroyed by sustained flight over depressions along which the jet may tend to travel, it was decided to hover the vehicle over the ditch and then fly out. In summary, the flight test program at Malton, concluding with this flight demonstration, was carried out concurrently with an extensive 54-hour test program on the second vehicle at Ames Research Center. The tunnel tests showed that if the known thrust losses were to be reclaimed, then the originally estimated performance was realistic. Also, that with the new transition control, transition from the ground cushion to in-flight was feasible. Throughout the entire Avro car development program, vehicle performance has been compromised due to thrust deficiencies, and it is apparent that if height and speed are to be increased, an increase in thrust is essential.